Hi folks, today I'm returned to the panel board of the Cisco KMM3000 TV Box receiver, okay? And after apply some reverse engineering, I have converted this board to a software development kit to the processor 8MB88. I have implemented on the board and has multiple examples how I can use the capability of the board, okay? I'm using the controller original, in this case 8MB88, but you can replace directly by the 8MB168 to gain more memory, because the pinout is direct compatible, okay? Let me try pass the concept and explain some points important to do it. And if you catch the idea, you stay with a powerful SD key to the microcontrollers of microchip, and very easy to use, okay? Is more powerful with a Arduino Uno, because it already have a display, in this case is a VFD2, okay? And 8 keys and the 2 LEDs you can use directly, okay? If you look to the board, I have implemented a lot of the actions to demonstrate how powerful is the board, okay? And the first thing I like to explain is here you have a button with 2 LEDs inside of the button, LED green and LED red, and the button is the press button normal, okay? And when I press the button, I assign the P in the display, okay? Okay. I try explain which is implemented in the board now, okay? You see the blink of the green, you see the blink of the red, but with different times, okay? Here you have the infrared receiver, and if I press the button 1, you see the code B8A, and the second time you see 8C5, and again 1, and you see B8A. It's happened because in the protocol of the communication I'm using, I have the bit toggle, is the third bit, and this bit change when they press the same button, but not change when you stay with the button pressed, okay? You need to study the protocol to understand what's happened here. Also, I have implemented a count here. Also, I have implemented the read of the keys, this key and this, a total of 8 keys. Also, I have implemented external interrupt here. Each time I press the button, the start change of the switch start interrupt, okay? If I press, release, press, release, press, release, okay? Each time the change happen, up or down, the interrupt take place. Here also you see a bar of LEDs running, and this bar of LEDs is controlled by one EC from the family CMOS. In this case is CD 4017, is a decimal counter. I send a clock, and also I have the reset button. The keys here is backward, first backward, backward, forward, first forward, up and down, okay? Each key you see something happen in the display, okay? In the middle I have the button C of the center, and when I press the button C, I release the counter of the LEDs, the bar of LEDs, or stop the bar of LEDs. Now it's stopped, okay? If I press the button, I release. If I press stop, press release, or if I press the button and stay with in down, the count take place, but another cadence of the LED, okay? You stop it now, count, stop, and also implement here a reset to the return to the home position of the LED, okay? Okay, this button, the P, interact with the LEDs because do it a reset of the IC, external IC, reset the counter, okay, and here you can see the P. This button take actions with 3 different scales, okay? Okay, this is the idea which is implemented to the board now. And let me try explain how I have done is. The first thing is necessary to do it is implement a reverse of the signal reset, okay? You need a signal from the reset here is coming from your Arduino, your interface to ML Studio, but if you use Arduino, here is the same, okay? You need to receive the signal here, the reset, polarize the base of the transistor, the collector will go to the pin 6 of the connector J1, and the emitter go to the GND, okay? This is necessary because inside of the board, I already talked about this in another video related with this board, you have the Q1, and the Q1 make the inversion of the signal reset to the pin 29 of the processor, okay? This is important things you need to take care with this, but it's very easy to implement, okay? This is implemented here in proto board, okay? And receive the signal, have here a pull up to the base, receive the signal negative from this case, and the collector go to the pin 6 of my connector, and the emitter in connected to the GND of the board, okay, of the proto board. Here you have the infrared receiver, okay. You have the receiver, in this case is V32338 or V32336, depending on the frequency you use, okay. But the board, the implemented in the board is 338. This receiver do it a trigger to the pin 32, in this case is the name PD2, okay, is interrupt 0 of the 8MB88 or 168. After you use the pin C3 to control the clock of the 4017, the pin D4 to reset the 4017, and if you look here, this pin is the 26 of the 88 and coming direct from the pin 7 of the connector 1, okay? The other pin is the PD4 and coming from the pin 8, okay? You can find inside of the code how you control these pins, okay? Now I only try pass the idea of the connection of the connector. To program the processor or the microcontroller, you will use the MISO, is the pin PB4, use the MOSI, pin PB3, you use the SC key, the PB5, and at last the reset. Don't forget, okay? This is the pin reset, SC key, MISO, MOSI, and this is 4 signals to program the 8 meg, okay? Here the PB2 is controlling the interrupt, okay? If you connect this point to the GND, you start the interrupt related to the PCINT2, okay? Here you have the mark to point the pin 1 of the connector. Here in the board also you have the mark to pin the connector of the power, okay? In the power you have the last 12 volts here, okay? GND, the filament here, these 2 points. Remember, you need to make the reference of the both powers to the filament to the last 12 volts, okay? Also for in this case I put here a small resistor, to example, connected between negative those volts to one of the power filament, okay? Or this, don't matter. The important, I remember, is you need use the 3 different power, okay? 3 independent power sources. You need use 5 volts to the VCC, less 12 volts to the VAE, and the 3 volts to the filament, okay? I remember, to polarize the filament, you can use the power of the 5 volts and insert in the serial with the filament 2 or 3 diodes 1N4004, okay? Because each diode will drop 0.7 volts, okay? This is a way to power up but the power source must be independent, okay? Also, I like tell to you which the PD6 is the button of the power, and the LEDs coming from the pin PC4 and the PC5 from the processor and go through R27, R26, and the PC5 control the LED red and the PC4 control LED green, okay? Let me try show you the matrix of the key and the pins which control the matrix of the key, okay? Here you have the PD5, PD6, PD6, PD5, PD7, PD5, PD7, okay? The pins or the port D, in the port D I use the 5, the 6 and the 7, okay? The other parts, the other pins you see related with the PD5 you have the PC0, okay? PD5 you have the PC0, and after you have the PD5 with the PC1, and after you have the PD5 with the PB1, okay? You have one PD5 and this PD5 interaction with the PC0, PC1, PB1. The PD6, you have here the PD6 do it action with the PC1, and here PB1, okay? You only have 2 pins PB6, okay? And after here you have the PD7, and this is related with the PCO and the PC1. Okay. To understand the protocol of the infrared, you need study, you need search in the web, because I have a lot of people to explain protocols you can use. In this case, I only let with you the names of the important protocols, okay? No return to zero, okay, is one protocol, one kind of the codification. No return inverted, okay? A bipolar with the alternative mark inversion is another protocol. Pseudo-tenar here is another protocol. Manchester is the code I'm using to codify the protocol I'm using at the board. And the differential Manchester, okay? Here the change only happen when you change the pin, the up or down, okay? I remember to alert you the receiver of the infrared already make the decoder of the portador or the frequency where you send to your receiver. You need to take care with the Philips protocol, RC5 or NEC, and the range of the frequency normal depending of the receiver and the emitter depend 33 or 40 kilohertz or 36 kilohertz or 5060 kilohertz, okay, depending of the protocol you use and your hardware you need to implement this, okay. This is done, this is done, this is done. I remember to deprogram the processor, you don't need to remove the processor from the board, okay? You will do it with the interface, in this case UTK500 or the ICE, other kind of the interface. Or you can do it direct from the Arduino, okay? And use 4 pins to the case, MOSI, MISO, C key, and reset. This is 4 pins allow to you program the processor on the board, okay? It's not necessary to remove the processor from the board to do the programmation, okay? And this is all. After this I let the code and I expect you can implement or catch the idea of the code and try implement by parts, because here you have a lot of implementations only to give you idea how you can control the board and how you can use, okay? In this case I already tell you, you have a lot of the controls processors in the board. You have the control of the bars, you have the control of the counter, you have the control of the keyboard, you have the control of LED green, LED red, and also the infrared. All these kind of the things is controlled by the processor, and the idea is give you one option to control your parts, okay? I let the code after this and try implement. If you cannot do it all at the same time, you can implement only the block you need, okay? Because it's the same as a controller Arduino. If you control the Arduino, you can control the board, because it's exactly the same thing, okay?